So today's topic is on moments, the turning effect of a force and the principle of moments. So before we begin the class, I'd like to show you one video about moments. So you have some idea on what is moments.
Think of a span loosening a fixed nut, or a child on the seesaw, or the door opening around a fixed hinge. All of these things are connected by something called moments. A moment is the turning force around a fixed pivot. The pivot is the nut, or the middle of the seesaw, or the hinge. We can have one moment acting which results in a turning force. Or if something is balanced or in equilibrium, the moments are equal and opposite. To be balanced, this lighter child needs to sit further away from the pivot, and the heavier child needs to be closer. This is because the size of the moment is determined by the force and a distance. So the moment of the lighter person is 500 newtons multiplied by 2 meters, 1000 newton meters. And the heavier person is 1,000 times 1 meter to also give 1000 newton meters. They are perfectly balanced on their seesaw. Did you notice that moments are measured in newton meters, Nm, because force is measured in newtons, N, and distance in meters? Note that the distance must be the perpendicular distance from the pivot to force. Here's another example. Can you work out what moments the woman is applying to tighten the wheel nut? Pause the video and work it out. Did you get 3 newton meters? Were you careful to change the 30 centimeters into meters? We can also place this formula into a formula triangle. Force equals moments divided by distance. Distance equals moments divided by force. And moments, as we already know, is force times distance. Here are 2 more questions for you to try. Pause the video and work them out. Did you get both questions right? For this seesaw, we do actually say clockwise moments and anti-clockwise moments. And for something to be balanced, the clockwise and anti-clockwise moments must be equal. So there we have moments. They're measured in newton meters and are the force multiplied by the perpendicular distance.
Okay, that was all about the video. I hope you will have some idea on the topic moments.
Yes, sir.
Okay, I would like to ask you one question. Why is the door handle placed at far end opposite to the hinge? So this is the hinge. Why is door handle placed here? Why not here or here? Why? What is the reason? So maybe you don't have some idea. So I'll explain. So if you look to the door from the top, like this is the door, and this is the hinges. It opens this way. Okay. So when the handle is placed far at the far end, more torque is achieved with less force. So it's easy to turn the door from here to here, but it's hard to turn the door from this side to this side. It's more harder. So to go on further, I'll discuss on this topic and show you some examples. So turning effect of a force, which is moment. Torque or moment refers to the turning effect of a force, and it is measured by the product of the force and the perpendicular distance of the force from the turning point. The unit of moment is Newton meter. You have to remember this because the unit you are going to write everywhere after the calculation. If you don't write the units, your marks may be deducted. So the formula for moments, or it can also be called torque, is force times perpendicular distance. Remember, it's the perpendicular distance, not horizontal or any other way. It's perpendicular distance. So if this is the pivot, a force, this is the plane and this is the pivot, a force is applied here. So the distance you are going to take is perpendicular to the distance. You can see 90 degrees here. So this is the perpendicular distance. To explain it further, I will show you an example. So this is the example. For the diagram given, find the moment of the door using a hinge as the pivot. So as you can see, this example, you can see plane is here about the distance, and the distance of the plane there is 3 meters. So this is the distance 3 meters. 3 meters. This is distance, and a force is applied at this end of the plane. So it is 5 Newton. So force here is 5 Newton. So you have to calculate moments. What's the formula for moments?
See, force times distance.
Good. It's moments equals force times distance. So what is our force here?
5 newtons.
5 Newton, that's correct. And what's the perpendicular distance?
3 meters.
3 meters, that's correct. So when you are calculating the moments, you must pay attention to the distance. It should be in meters always, because the unit of this is Newton meters. Okay. So here we have already the distance in meters. So 5 times 3, it's 15. So it's 15 Newton meters. So this is our moments for this. Now we'll go and discuss more about moments. There's a topic on principle of moments. So what is principle of moments? Principle of moments states that when a body is at equilibrium, the sum of clockwise moments about any point equals the sum of anti-clockwise moments about the same point. For the formula for that is sum of clockwise moments equals to sum of anti-clockwise moments. So you can see this is like a seesaw balance type situation, which you use in real life, of course. Like you have to calculate force for a particular person, what force is applied, or what's the weight of a person. You can use this formula. So you can see an example. Find the value of force in the system below, so that the beam is horizontally balanced. So you have to find the force here that the beam is balanced properly. So I will show you how to do this question. You can get this marker working. You can say this one is example 2. Example 1. So it's a plane. We have a pivot point here, and a force is applied at some point this, which is 50 Newton, and a force is applied here, which is F. So this is a mystery force. For the first force, the distance from this point to this point D equals 20 centimeter. So we can name this one D1, 20 centimeter. And force here, distance here is 15 centimeter. 15 centimeter. You can label this as D2 equals 15 centimeter. So we have to find what's the force applied here, so that the beam is horizontally balanced. So we have to use the same formula, sum of clockwise moments. Equals sum of anti-clockwise moments. So as you can see, when the force is applied here, so doing this kind of question, when you are looking at forget about the rest for a moment. So when force is applied here, a fulcrum is here, a pivot point is here, so it will move, the beam will move in this direction, which is anti-clockwise. That's correct, that's anti-clockwise. So the formula remains the same. F times D will name this, this is D1 and this is F1. So F1 here is 50 Newton and our distance here is 20 centimeters. But at the beginning I told that it should be in meters.
Yes.
So this is equal to 0.2
2 meters.
meters. So 50 times 0.2, what's the answer?
It's 10 say.
Okay, 10 Newton meters. So now we're looking at this force. When force is applied here, a fulcrum is here, so it will move in this direction. What is this direction?
Clockwise say.
Clockwise. So the formula will say F, will name this F2 times D2. So we don't know F here, so F remains F, and D2 is 15 centimeters, so we will change that to meters, which is equals to 0.15 meters. 0.15 meters, so this is 0.15 F. From here it's just simple mathematics. Divide by 0.15, divide by 0.15. Force is equals to
66.67 newtons.
66.67 newtons. That is correct. It's the force, so the unit will be newtons. Okay, to go on, I will discuss another example on this, so you guys understand it better. You can see also see the same thing I did on the board. Just did some few extra steps there. We'll move on to example 2 here. So the seesaw balance when the sway of weight 320 Newton at A. So this is point A. He sits at 320 Newton, the force of our weight, and two of weight 540 Newton at B. So this is 540 Newton. This is F2 here, the force applied, and getting of weight W is at C. So that is point C. That's W. Find W a weight that will balance the seesaw weights. So it's nothing hard, just using simple formula. So sum of clockwise moment equals sum of anti-clockwise moment. So when a force is applied here, so this will move in this direction. So this is clockwise or anti-clockwise?
Clockwise.
Clockwise. So W times what is the distance of W from the pivot point?
3 meters.
3 meters. So we'll do W times 3. Okay. It is force times distance here, to force times distance. Our force is W here, and our distance is
3 meters.
3 meters. And now we go on the other side. You can see there is two forces. 1, 2. So you can do it one by one. So when forces this is applied, this will go in anti-clockwise. So 320 times what is the distance from of A from pivot?
3
3 meters again. So here we'll do something different because there's two forces. So F2 times D2 plus F3 times D3. So F2 is 320 Newton times what's the distance? 3 meters plus what's F3 there? The second force is also anti-clockwise. When this force is applied, it will go like this, which is anti-clockwise. So 540 Newton times what's the distance from the pivot?
1 meters.
1 meters. So 540 times 1. So can anybody do 320 times 3? What's the answer?
960.
960 plus this one for 540 times 1. This is 540. Now you add this. What 960 plus 540?
1500.
1500. Okay. So on the left hand side, you can see W times 3, which is 3W. 3W will come here. From here, it's simple algebra. Divided by 3. Divided by 3. W is equals to
500.
500. So there you can see my answer matches properly with the solution given by the head of department. So I would like to give you a homework. So this is just a simple question. Previously we discussed about seesaw balance and anything, but here you have only one pivot point and the plane is this side, two forces are applied. So same thing will do. Sum of clockwise moments times sum of anti-clockwise moments. So you can see this force here. You have to find this force. If this force is applied here, it will go in
Clockwise.
this will go in clockwise movement, clockwise direction. And when this force is applied here, upwards is applied, here's the pivot. It will go like this. Which direction is this?
Anti-clockwise.
Anti-clockwise. That's correct. So I'll check this question tomorrow. All the best for you to do this question. Thank you. That's all for today's class. Any questions?
No, sir.
You?
No, sir.
Thank you.